Hi, thanks for joining me once again. We're going to continue our talk on dividing polynomials, and this time we're going to talk about synthetic division. So synthetic division is an alternative to long division that we can use to divide polynomials by linear factors of, say, x minus k, where k is some constant. Synthetic division cannot be used when dividing larger polynomials, for example, like a quadratic into a larger polynomial. So that's when we will not use it. It will only be when we have some linear factor x minus something. Okay, so in our first example, just a basic division example here, divide 3x cubed minus 4x squared plus 2x minus 1 divided by x plus 1. So I wanted to show you, here's what it would look like if we did the long division setup. You don't necessarily have to do this step, but this is what it would look like if we did that. And I want to show you how that relates to synthetic division. So the nice thing about synthetic division is all we need for synthetic division is the coefficients in front of each of the variables, as well as the constant, and then this minus k term here. In this case, remember the minus k, x minus a negative 1, we could call that. So our number in here is, the k term is negative 1. I should just make that, this is k. K is negative 1. Okay, so how you set it up, you bring down your coefficients and then put in what you're dividing by, which in this case is the negative 1. Okay, so here is the process. The first thing we want to do in this process is just bring down the first number, in this case the 3. So I brought down the 3 already. Okay, so bring down the first number, then multiply. So we're going to take the 3 and multiply it by what we're dividing by, in this case the negative 1. So 3 times negative 1, and where we write that is under the next number, the next coefficient. Okay, so 3 times negative 1 is negative 3. We write that here. The other nice thing about synthetic division is instead of subtracting and having all sorts of problems with negative signs, synthetic division is easier because we're going to add instead. So when we add here, negative 4 plus negative 3, we get negative 7. Again, it's a little less likely to make a mistake because we're adding instead of subtracting. So that's kind of a nice thing with synthetic division. Okay, so now that we've added straight down, we're just going to repeat that process until we get all the way through all of the numbers. So negative 7 times negative 1 is positive 7. We write that under the next column here. And once again, once we do that, we add straight down. So 2 plus 7 is 9. And now repeat the process again. 9 times negative 1 is negative 9, and we are going to add, and we get negative 10. Okay, so here's the tricky part. The tricky part about this is rewriting your answer. So we have to remember this last number here is always the remainder. Okay, so always the remainder. So sometimes that remainder is going to end up being 0, which means this number is a factor, because we've talked about that already. If the remainder is 0, this is an exact factor of our polynomial. In this case, it's not a factor. So we have to remember this is a remainder. So this is our constant term. This is the number at the end, plus 9 with a remainder of negative 10. Okay, and so from there, that means this is the linear term. So the minus 7 is going to have an x with it. And then the term before that, the 3, this is going to be 3x squared. And we will kind of know if we have the correct variables in front of these if the quotient should always be 1 degree less than the dividend. Because we're dividing by a linear factor. So since we're dividing a cubic in this case by a linear, we should have a quadratic, or 1 degree less left over. And we do indeed have the quadratic left over. So we know we've put our variables in correctly here. Okay, so best thing to do is just continue on, and we'll look at some other examples here. Before we look at some other examples, I want to talk real quick about a thing called the remainder theorem. The remainder theorem says if a polynomial p of x of degree n greater than or equal to 1, in other words, it has to be a linear, quadratic, or cubic or something. It cannot be just a constant. So if a polynomial p of x of degree n greater than 1 is divided by x minus k, where k is a constant, then the remainder is p of k. Okay, we're going to look at that here in this example and see what that means. So we're going to use synthetic division and the remainder theorem to find p of k. So what the remainder theorem is telling us is whatever the remainder ends up being here, that remainder should be the same as when we take this number and evaluate our polynomial at that value of x. Okay, so over here I have evaluated our p of x, call this p of x, x cubed plus 9x squared plus 12x minus 7. I'm evaluating that at -3. Okay, so if I put in -3 for x, -3 times -3 times -3 is -27, plus 9 times -3 squared. Well, -3 squared is 9. 9 times 9 is 81. And then 12 times -3, that's -36, minus 27. And if I add all that up, I get -9. Okay, so we're going to see what happens when we use synthetic division on this now. So here it is with synthetic division. I don't have a reminder over here of the process, so remember that process. We bring down the first number, and then we multiply. 1 times -3, and we write that value under the next number, and then add straight down. So 9 minus 3 is positive 6. Okay, from there, 6 times -3, well, that's -18. And we're going to once again add straight down. So 12 plus a -18 is -6. And we're going to multiply one more time. -6 times -3 is positive 18. So -27 plus 18 is -9. So notice this remainder here is the same as if we just plugged in -3, whatever it was we divided by, the -3, if we plug that into our polynomial. We get the same value here either way. Okay? So that's what the remainder theorem is. That's what it does for us. Okay? Example 3. Use synthetic division to determine whether the given binomial is a factor of this polynomial. Okay, so there might be an instance where we want to check some different values and see if that number would give us a factor, a linear factor of our polynomial. So we're going to do that here. So we're going to see if one of these is a factor of this. Okay, so remember we need x minus k, and this is plus 2. So I'm going to make this -2 here. So first step, bring down the first number and then multiply. 1 times -2 is -2. And we're going to add straight down. 6 minus 2 is 4. 4 times -2 is -8. Add straight down. -1. -1 times -2 is positive 2. And we're going to add straight down. So we get a remainder of 12. So remember, in order for it to be a factor, we have to have a remainder of 0. In this case, the remainder is 12. So this, x plus 2, is not a factor. Okay, we're going to try -5 now. So -5. And so if we put in here, bring down the first number, 1. 1 times -5 is -5. And we're going to add. So 6 plus a -5 is a positive 1. 1 times -5, -5 again, add straight down. This becomes 2. 2 times -5 is -10. When we add, we get a remainder of 0. So since our remainder is 0, x plus 5 is a factor. So because the remainder is 0. Okay, so that's why we know it's a factor, because that remainder is 0. Okay, so that's it for that one. One last example. Use synthetic division and the given factor to completely factor the polynomial f of x equals x cubed plus 4x squared minus 11x minus 30, and we're going to use x plus 2. So here is where we're going to use some of the new information, the synthetic division, and once we have that, we can factor the quadratic that's left over. So we're being told that x plus 2 is a factor, so we should expect our remainder to end up being 0 here, which once we get done, we'll see it is. So 1 times negative 2, this is negative 2. When we add 4 minus 2, we get 2. 2 times negative 2 is negative 4. When we add negative 11 plus negative 4 is negative 15. Negative 15 times negative 2 is positive 30. And so when we add negative 30 plus 30, we get a remainder of 0. Okay, so we have to remember now, how do we have to rewrite that? Well, remember, this is our constant, minus 15. This is our linear term, so this is going to have an x with it. And this is going to be our x squared term. Okay, so we're just going to rewrite it. X squared plus 2x minus 15, and then rewrite it as x plus 2. I'm going to go ahead and write in the f of x equals here. Okay, so from there, this is something that we can now factor. If we couldn't factor it, we could also use quadratic formula. If it was something we could solve using square roots, we could do that. So any of those tools that we have to finish solving this quadratic, we can bring in at this time. But this one is nice and easy. It's going to factor very nicely. So we're going to factor this. So think about two factors of negative 15 that add up to 2. Sounds to me like 5 and negative 3. So we're going to have plus 5 and negative 3 gives us the negative 15. And x times x gives us the x. We can double check. X squared minus 3x plus 5x, that gives us the plus 2x. 3 times negative 5. 5 times negative 3 is the negative 15. So we have finished that off by factoring the quadratic. So we have completely factored the polynomial now. So this is equal to this when it's completely factored. Okay, so hopefully you see the process of synthetic division now, and you'll be able to successfully do this. Thank you once again for joining me, and have a great night.